Hello and welcome to USMA Orgo. We're now up to chapter 8, and this is a second chapter on alkenes and alkynes. There are quite a few reactions in this chapter, so instead of writing them all out, I'm just going to talk about them in general terms, but it's incumbent upon you to go back and really study these reactions in this chapter. We'll be using these the rest of the year, so understanding the mechanisms is very important. First section we're going to talk about is converting alkenes to alcohols. So there's many different ways to do it, and there's some nuances about them that you have to kind of pick out. But we're going to talk about the acid catalyzed hydration, which you're just using an acid and water, and that's what we call a Markovnikov addition, which we'll talk about in the next slide. Not much stereo control here, and there is possibilities for rearrangement. And then there's the oxymercuration, demercuration. So we're going to have quite a involved set of reagents that give us a Markovnikov addition again, and you get to put the you make an alcohol out of certain types of alkenes. And then finally, hydroboration oxidation. Now, I'll be mentioning this many times, but when you see something that has peroxide in it, usually something weird's going to happen or something different's going to happen. And in this case, it makes an anti-Markovnikov addition. So make sure you pay attention to when you see that reagent in the reagent set that you're going to have something different happen, which in this case is the anti-Markovnikov addition. So again, I didn't put all the mechanisms on here, but you need to know the mechanisms, understand them, and go over and practice them, rewrite them over and over again so you get them down, and then it'll be easy to understand what type of the predicted products of a reaction. So Markovnikov addition simply is, there's a few ways to state it, but the most simple way is saying that when you add a hydrogen, it's going to go to the side where there's already more hydrogens. So that H goes here, which ends up here, as compared to an anti-Markovnikov. When you add the H, it goes to the less stable side, which is here. And so you get the hydrogen to the less stable side. So in this case, it's showing you that Markovnikov, why Markovnikov rule gives you the major product, and that's because you have a more stable carbocation in the middle there. But in certain cases, like I said, when you have peroxides, you're going to see that you're going to be able to get an anti-Markovnikov addition, and the anti-Markovnikov addition, no matter what you're adding, whether it be a bromine, an alcohol, or whatever, you're going to get the hydrogen is going to go to the side where there's least amount of hydrogens in an anti-Markovnikov addition, and the other component will go to the side where there's more hydrogens, which is the anti-Markovnikov situation where you have the peroxide. So again, told you there's a lot of reactions in this section. Here's the summary from the back of the book, and we talked about the making alcohols, which some of these show some of that down here. But then there's also at the top the hydrohalogenation, so when we're adding basically a hydrogen and a halogen across the double bond. Okay, and the same thing you can do acid catalyzed hydration, which is what we talked about with making alcohols. And then the halogenation is when you use an X2 or Br2Cl2, and they add one halogen on either side of the double bond. You can also do that with, if you have halogen and an alcohol or water, you can add the halogen on one side and the alcohol or water on the other side. We talked about oxymercuration, demercuration, and then there's the dihydroxylation. So in this case, we're using the osmium tetraoxide reagent set. You're going to get two alcohols on either side of the double bond, and they're going to be in what's called a syn addition, which means that they add on the same side. So again, take a look at these different reactions. understand the different nuances, and it'll be easier for you to know the mechanism and predict the products in the future. So the last slide here talks about alkynes and how alkynes kind of interrelate everything else. So some of these are a review from the other slides, but if you start off an alkyne, you can go many different places. So you can add a hydrohalogen one time and get an alkene with the hydrogen and a halogen attached. If you do it a second time, you can get two halogens and two hydrogens added across where the triple bond used to be. Same thing if you use dihalogens, you can get, so you have four halogens attached across the triple bond. Now some interesting things we talked about last chapter using hydration. So not hydration, but adding hydrogen, reducing the double bond, and the different ways we can do that. And there's also these ways of converting them to carbonyls using osmium, or excuse me, ozone. We have some unique cases where you can create a three-membered ring. Again, the adding hydrogen across double bonds, another three-member ring, unique situation. And then in this case, now you're being specific about the type of conformation that you want the double bond to go in, and once you get that, using a strong oxidizing reagent, you can oxidize using potassium permanganate all the way to the carboxylic acid. Okay, if we want to go from the double bond back to the triple bond, you can do that. We did that last chapter. And so quite a few ways to convert back and forth. Again, a lot of reactions in this chapter, so you really need to buckle down. I suggest writing these and rewriting these, doing the mechanisms, understanding what's going on. And once you understand that, then it'll be pretty easy to predict the products as you go along. We introduced a reagent sheet last chapter, so make sure you understand the reagent sheet and you can translate those reagents to what they actually do, so that you take good notes on that sheet and make sure that you can use that for studying and getting organized when you're getting ready for the next test. Alright, that's it for today. Have a great day.